look like Fred Flintstone.
Oh, yeah. So what we do with, forget about those avatars sometimes, and I just happen to have one that I had in, I could draw on an ANSI terminal screen, and had a Fred Flintstone I used as a test image. So that ended up there, and you forget all about it. That's what happens. Yeah. Yabba dabba doo.
Okay, well, let's get started, everybody. I want to welcome everybody here tonight. This is the first of our Propeller 2 live forums for anybody that wants to share anything they're working on, likely early adopters because you're the only people that know anything about the P2 so far. So tonight we have testing hardware with TAQOZ and ROM. Everybody likes tacos. With Peter Jakacki and Ray Rodrick. Thanks, guys. I know it's you're in a weird time zone, like 2/3 of us here, so we appreciate that. Before I turn over to you, just a little bit of housekeeping, small stuff, just so we all know. The P2 Rev-C chips are in stock now. They came in yesterday, and I think you can see the screen that I'm sharing. Cool, okay.
Nice.
So just so you all know, we have 2,700 units. It takes us 16 weeks to get more, and we've not placed an order for production yet, but we're talking about that and just trying to figure it out. So you can get what you need. We have a few stashed away for those that overlook or come in late or find out they need more or whatever. In terms of eval boards, we're all sold out of those. We have this Rev-C in the works, and the changes to it were significant enough that we had 20 new parts we had to stock, and a lot of them went out of stock at Jakacki and Mauser when I was trying to buy them. And it looks like the soonest we're going to have this is the end of June. And if you want, Chip can probably talk about what's different with it later on. And then next, we have a need for P2 objects, a very desperate need. I'm relying on Chip, and Chip's working on the debugger, so I'm starting to turn more attention to all of you soon. So there is a list. I'm going to share it in the chat in a few minutes, but this is not the end-all list. You can really create anything you want. What will we do with these? As you know, we took OBEX down because we were really unable to maintain it. It was getting spammed. So we have this propeller.parallax.com site. And for the time being, we will start to post objects on this page near the bottom. And we're just going to manage things manually for a while until we get a grip on what we've got. And for those who are just joining in and don't know where we're going with all this, you can follow it on forums.parallax.com. And if you go to the Propeller 2, there is a thread which continually appears called Propeller 2 Live Forum. And the very first post of this has in it the presentations that are happening or have happened. If they've happened, I'll post the YouTube video. And if they're going to happen, the registration links are right here. And as you can see, we got the first one tonight, which is, or this morning or this afternoon. And then Ray Allen is talking about graphics next time. And then we got Eric Smith, Fast Spin, Flex GUI. And then we got more from the Oz people with MicroPython, and then John's going to talk about smart pins at one point, and then I'm going to have Chip talk about the debugger stuff he's doing. So we got a whole summer of things to do here. It's going to be a lot of fun. So if you're new to Zoom, don't worry about it. You can use the chat, ask me questions. I'll help you along as we go. And you can unmute your microphone and ask questions or type them and make yourself at home. So with that, I want to thank Peter and Ray a whole bunch and pass this over to you guys.
Well, thank you very much, Ken. Thank you too, Chip and Parallax, because, we get really excited about electronics and our software, the Propeller. And you all feel the same, where, we go by different names for misters and prop heads, and I don't know, but what we do is have fun. And that's what I want to do is today, really just show you that we can have fun, and it doesn't take a lot to do that. We have TAQOZ and ROM, and I'm not sure if you all remember how this came about, but Chip was originally doing the ROM, and he put the serial loader in there. That was really good. And the thing is, all took up about 2K, and he had a 16K ROM. What else can we put in there? Well, there's a lot of stuff you can't fit into 14K, but you can fit in a fourth. Why a fourth? Because the reason being is that once it's on the chip, you can use it to debug the hardware. Very useful. If your flash isn't working, nothing else is working, but you can talk to it, then that's what we can do. Now, with TAQOZ, this was originally developed as Tachyon on the P1, and then I developed a version for this on the P2, on the FPGA versions that went through a few different iterations. So by the time we came to doing a ROM version, Ray also jumped in. He says, look, I can do the SD bootloader, and I can do a little debugger and machine code. So yes, I ended up with 12K, and he took 2K out of that, and so 16K altogether. Worked out well, and I didn't have to worry about the SD bootloader. It just had to work. Now the thing is that I'm going to share a screen with you now, which is my Visual Studio Code screen. Hopefully I've got this right here now. So bear with me for a moment as I do this. Okay, here we go. Now, what you should be able to do is see that screen. Okay, that's good. So at the moment, it's fairly simple. What I have up here, I have my source code that I use, the TAQOZ fourth one, etc. There's various modules in there, and the kernel modules such as I've got some other ones in there. I'm getting confused what I'm seeing here now, but this other stuff is to do with the little USB chip I have on there, so I'll leave that out of there. But over here, I also have, over this area over here, I also happen to have the terminal, which is running Minicom. Normally, it's just a, you like that? I didn't mean to do that. Okay, well, stop that. Now, up here, what we're going to do is we're going to pull out the SD card out of the P2 eval board, reset the eval board. Now, hopefully, can you guys see that text there? Is it okay? Just sort of just say so. If it is, what I'll try to do is I might even see if I can adjust that up a little bit.
Yeah, maybe
okay?
up a notch. And also, which editor are you using?
Okay, this is Visual Studio Code. Now, we're mentioning this the other day. Quite a few of us are using this. So Visual Studio Code, see if we can get this up here. This is the Linux version that I'm running on. And this is a Microsoft product, believe it or not. But I'd been using all these other editors before. And I had Atom Editor, which is an open source one. This seems to be about the same, except it's better. And so I quite like it. And the fact that we have a terminal shell, I can Control J in and out of the terminal down there and go back into the editor. I can split up the screens, etc. I can split it up this way, go over there, move it around, and I have over here, my left-hand side, my file window. Another interesting thing with a file window, I might show you a bit more of this later on, is that we can also put other things in there. Watch this. Here we go. Oh, we have waveforms as well. So that's really neat. So we can have the terminal, the waveforms, and the source code all in one. I'll just take that down from there now. And just coming back across here, what I want to show you is once I've reset the P2, it'll be unresponsive. So I'll jump out of the Minicom, come back into it again, nothing going through the keyboard. No, that's good. It's hooked up 921/600 board, but the sequence that we use from the terminal, remember chip has it auto boarding anywhere up to 2 megabaud using RC fast internally, which is a bit faster than the original RC fast. Original RC fast was about 22 megahertz. I noticed that a lot of these Rev B and probably the Rev C chips are 25 megahertz. However, we'll use the auto board sequence, the greater than space escape. Oh, there we go. You can see that. We get a cold start up there, down the bottom here. And TAQOZ. If I hit the enter key, it'll say okay. Nothing much at the moment, but this is the basics. We know the hardware is working. The serial comms working. the oscillator mightn't be working, the flash mightn't be working, the SD card mightn't be working, but this is working. That's good. So let's have a look at the I/O first off. We have a command in there, which is in Linux, we have a lot of ls commands like ls USB for listing USB devices or PCI devices and so on. In this case, I've called it ls/IO. Logical enough. List the I/O. What do we have? And what it shows me is, if you're following along, and you can follow along in the ROM, and everyone has the ROM on their P2, that's a good thing. We can see that here's the I/O, P61 down to P00, right up to P61. And in there, we have P61's a pull-up high, pull-up on that particular one, and pull downs on some of the other ones. I happen to have VGA plugged into there at the moment, so you'll see the pull downs from the 75 ohm termination impedance. Now, what else can we do? Well, we can check the flash is working, because maybe we've had a problem with flash. Easiest way around that, I have a
44 MIN until full.
Okay, right. So we have a .sf print SPI flash, serial flash, and it spits out a manufacturer ID and serial number and so on. So that proves the flash is working. We can even dump out the flash. The normal syntax in Forth is to have numbers and words separated by spaces. If you want a number, you've got to put it on the stack. So get your number first. Okay, 0. I'm going to go from 0. Okay, put that on the stack.
Position your swipe up
And then
to open.
look.
Charging stop, battery level 61%.
Okay, that's not mine. Okay, so we're going from 0, from address 0 for 256 bytes and dump. And notice I have space in between, or many spaces. It doesn't matter, but this is a general format. That's just listed out what I happen to have in RAM at the moment. Now, because the way it's written, I can also specify a different memory device, serial flash or SPI flash, and it has something similar in there at the moment. But I happen to know that I'll just jump up to another address here, right up high, for where it's all FFs. So this is definitely serial flash. It's not RAM at all. RAM itself is over here. Now, just bear with me for a moment, because I'll just show you these basics here. And there's RAM there. It's a totally different data there as well. Now, what we can also do, we've checked out the flash. It's working. That's good. .sf, the flash is working. We checked out the I/O. I/O looks right, and I happen to know I have the VGA plugged in there as well. We have an SD card. Let's plug that in. We should see a difference now in ls/IO, because when you first insert an SD card, the chip select line of the SD card has an internal pull-up. So we should see that on P60. Let's see that now. Up here, on P60, we now see a high on there. I hope everyone can see this clear enough. We're setting the bar low just to make it easier for the next Zoom meeting, by the way. So we have high on there, and what I can do is mount that. Well, in fact, what I can do, before I even mount it, which requires mounting a file system, I can just say, look, initialize the SD card. I use an exclamation point preceding the SD to indicate initialization. It's just my syntax. And let's print out the result. Yes, it's got a result, so it's successful. So I'm going to tell it to mount that card now, and it's mounted that, and it looks into the CID of the card and tells us that it happens to be an SD, etc., and the serial number and anything else, and the number of bytes per cluster, and the overall size, which is not quite 8 gig. That's fine. Now what we're going to do is do a directory of that dir. There we go. So we have nothing loaded onto the P2 board. You have a P2 board, put your card in, you can check out your serial flash, you can check out your SD, you can check out your I/O. Talking about I/O, by the way, we've just seen that the card works. We can do a few things with that. We'll come back to the I/O in a moment. I'll just show you what we can do with a file. This version of TAQOZ doesn't have the full file handling in it. So I have to use a sector number that I happen to have over here. I'll pick a sector number out and open up a file using that number. So let's have a look at this bitmap file. What we'll do is we'll open up this sector number 30. In fact, I might even just copy that, paste that in, and tell it to open up that file. Now, if you're following along what's happening now, I'm using a sector to specify the starting sector of the file. And on an SD card, I haven't found it any other way, but it's always contiguous. So I've never had problems with that. Once I've done this, here's a little trick. I want to double check that particular file. I'm going to specify dump for the first 256 bytes, but using the SD as the dump device. Now, if you recognize bitmap files, the very first two characters are BM, and here's the header and so on. So this is important for debugging. We want to make sure our files are right, the directory is right, FAT32, the SD card, everything about the board. So we don't have to go anywhere else but to the ROM to do this. Once we've done that, we want to play a little bit too. We want to make sure that we can, well, what I might just do is I might just get it to create a tone. I happen to have speakers plugged in at the moment. I think they're on 6 and 7, same as the VGA board. And I'm going to tell pin 6. Over here, I'm going over to pin 6 and notice the format I use. Specify the number, specify the action. So 6 is the pin, and I'm going to tell it to, might be a bit loud, so bear with me, a 2 kilohertz tone. Okay, please mute that. That was nice and easy, wasn't it? How about we play a few tones? We'll jump up in from 100 hertz up to 3 kilohertz, and we'll go up in steps of 100. Here's a quick little loop, one-liner. Once again, testing out hardware. So I'm going to say start, go up to 3000, start from 100, do, and within a do loop, we specify the limits and the starting index. We can also take, we can read that index with an I. So the index there is an I, so I'm going to say to it I, and this particular case hertz because it's not kilohertz we need, and just wait 50 milliseconds. I don't want to wait too long, and hopefully at the end of it all I will tell it to mute. If this works properly, I'll be amazed. Okay, taking way too long, but you get the idea that we can test out the hardware very easy. Any questions at the moment?
Peter, just before you go on, what I was seeing on the screen was I was just missing the line that you're actually typing on the bottom of the screen. I don't know whether the same happens with anyone else.
Okay, what I'll do is I'll just paste this up into another screen up here. I'll paste up that line, and I'll see if I can. This one does not do the zoom function on there very easily, so I'll see if I can increase the font on here for better zoom viewing. Now, just give me a moment. I've got to find out where have I got that font in there. I know what, I've got other ones here. This will do. It won't share. We must remember we're on Zoom, so it's sharing.
And maybe a question that Ray can answer while Peter gets that set up. What's the best
Yeah.
place to learn the individual commands on TAQOZ? Is it the documentation on the forum thread?
Well, by the way, you know, talking about that, there is some documentation. What really needs to happen, I guess, is that we say, okay, the ROM is fixed. And this makes it easy because we can say, well, this is what this part does. It won't change. This is fixed in ROM. And so I probably need to update the ROM document there, TAQOZ ROM, and that will make it a lot easier. If you're familiar with Forth in the first place, well, it shouldn't be too hard, but bear in mind that the prop and TAQOZ is to the prop what prop is to any other micro. So it's different as well. So that probably needs to be documented as such. Now, I don't know if you can see that, so I will just go back again and see if I can find the font size for that one, once my mouse works properly.
Just so you know, Peter, the bottom line that I'm seeing is 400 asterisk P2 clock asterisk, and it's 90% showing.
Okay, all right.
Now I can just see the dashes.
Yeah, so, okay, so I probably need to, I'll do that again.
You have screen zoomed in? Is that why you can't see the bottom line?
Okay. All right. So I've taken the SD card out now. Put it down there. I've reset this once again. I'll try that once again, and I'll go into TAQOZ, into the ROM, and I'll move it up a little bit like that. I'll put that one in again, but this time I will change it so it doesn't go for as long. I'll jump up in. I know what I did wrong. I didn't jump up in 100 steps of 100. So okay. So I'm going to do that again. This time it's jumping up in steps of 100, and it should end fairly quickly. That's what I wanted in the first place. So there was a little bug there. I'll put that up a little bit further, and all I did was told it to increment the loop by 100 each time. And that's really the sound effect I wanted. That's TAQOZ. How am I going for time there, Ken? How are we doing?
You are 22 after. I think you're fine.
Yeah, okay, that's fine, because what I'd like Ray to do is, while we're in the ROM, is to talk a bit about his part in the ROM there. And then I can come back to TAQOZ. I can increase the screen size here as well, the font size. And I'll talk about TAQOZ Reloaded. So yes, similar to the ROM, but far more. Okay.
Just before I take it, Peter, why don't you go through that line and explain precisely what it's doing for the ones that don't follow Forth, me included.
Good. Yes, I'm sorry. So yes, that's a good question. And what I'm going to do is that was a one-liner that was compiled, executed, and the memory was released. What I'm going to do is create a definition, a new definition. We're using the familiar spin notation of pub.
Peter,
for public. Yes.
Is it possible to move the frame that holds the terminal window to the top part of your screen?
Yes. So what I'll just do is see if I can do that. Or
you could share the application window instead of the screen.
Well,
that might work better.
What I'll just do is, in fact, I will exit out of that one. I'll open up. Why doesn't it go up this way?
Just before you do, Peter.
Yes.
That line that you've got, which we can all see, it's both at the top of the screen and down near the bottom. If you just go through and explain it like 6 pin means pin 6, and walk through the line like that.
Good. All right. So what I'll do here is I'll use this up in the editor up here. If you can see that okay.
Yep.
Then we've got 6 pin. Now, what I like to do is, rather than specify the pin number for every single action, I have a pin latch in there registered. So once I set pin 6, then anything that wants to refer to that will just refer to that. And I don't have to keep specifying it. So 6 pin does nothing itself. It just simply sets internal cog memory. Takes that parameter away, and it's gone. After that, I go through and I want to specify a loop. Now, loops in fourth, we have a nice for next loop, which is simply just a counter. It'll be, say, 10 for something next. 10 times, starting index is always 0. The do loop, the top of the stack parameter here, the 100, is really the starting index. And that it will use, and it will keep on counting. Every time it encounters a loop, it will keep on counting up to 3,000. That's what this particular part of it does here. So that particular part there, 3,100 do, simply specifies a loop. It gets stacked along with a branch address as well in TAQOZ. So now it knows it needs to come back to this spot here when it encounters a loop. The next thing I do is get the value I, and this will simply return a value on the stack, which will be the current index, starting at 100. So we can imagine that's 100, and we pass it through to a definition, which really creates an NCO counter out of one of the smart pins, and just works out what frequency it needs to do that at. So I hertz will be 100 hertz initially, and then we wait. This is nice and simple here, I hope, 50 milliseconds. Little delay, so we can hear that tone. Then the mistake I made before, I was simply looping, which is incrementing the loop by 1 every time and taking forever to do it. Now I tell it to increment by 100 and use a similar word plus loop, which will do that. Once it's all done, it will mute that. So if we try that out, I'll put this back together again, like that. Grab that, put that in here. I did something wrong there, didn't I? Okay. And that was nice and easy. So this gives you a quick idea of what you can do to test anything out. And now, just what I'm going to do next is put that inside a definition. Build a definition, a pub definition, which we're familiar with. In this case, I'm going to call it demo, nice and easy, demo. All right. And I always finish off a definition with a semicolon, which is like a return from subroutine, an exit. So if I grab that now, I can put that in here. And the word demo belongs in the dictionary. If we look at the dictionary words, we might see that here are all the wrong words we have. And right at the very top is the new word called demo. So now it understands what demo is. If I type demo in, it does all that. So that's how we can create a definition. We don't have to do one. We can just simply print hello world, hello world. Remember, this is the ROM version, so it doesn't have quite everything in there, and I need to remember that. Print hello world. Nice and easy. Yes, so how am I going for time? Any questions?
Hey, I have a question, Peter.
Yep.
So I see that what's in the ROM is like the basis for starting to build things.
Yep.
So if someone wants to make an application using this and they add definitions like you added demo, how can they save that off so that it, say, comes up every time they run TAQOZ? Or
yeah,
so that you can really start building things with it.
Yeah, well, you know, this is what we thought about in the beginning. You could, if you had no other tools, and as we say, you're out in the sticks and you need to write a little app, you can do it. I do have backup to serial flash in here as well.
Okay, so
really,
you can talk to the flash chip.
Yeah, I should be able to say backup. I'm guessing yes, it backed up to the flash just then, but that won't automatically boot. You still need to auto board into TAQOZ from chip side. It comes into TAQOZ when we hit the escape key, and then from there we can restore from there, restore all that. So I believe, I haven't tried this out for a long time, but if I powered this back up and did a restore, or Control R, we'll do a restore, then all the words I had there before will still be there.
So you could have like a really verbose, like a really rich version of TAQOZ that you can restore every time, right?
Yeah, and certainly you can do that. But I think, you know, what the thinking was, well, if we can do that, then we can load in the full version of TAQOZ, which has far more in there, and boot that off. Well, in fact, I don't have it booting out of Flash at the moment, but that's a fairly easy thing to do. I have it booting from SD mostly.
So it's like it's like a whole development system that doesn't require an IDE, only a serial terminal.
If that's all you had, then you could write all the tools you needed, even with the ROM. But the primary advantage of TAQOZ and ROM is, of course, hardware testing, sanity checking. You know, a number of times we don't understand why something's not working, can't get that little micro SD card working. We can check it. We can go into the files and check the files. We can check the hardware.
Well, you could download a version into the Flash that it boots up with, right?
Yes.
You could have a state-of-the-art version. And then if you had that, is there a way for the user to partition their own dictionary from the basis of TAQOZ?
Yeah. Yes. Well, you know, with the with TAQOZ, or Forth, when you create your own words, they become part of the dictionary. You can
Right.
partition it. I do that automatically. I have the kernel that I might load in. No, I might load in modules. I have a header in that module there, and I can always forget all of that code and strip it back out again, or I can perform a cold start and strip everything right back down to the basic kernel. This is what I do now with the kernel that I load in. You might notice, though, that over this other side here, I've got another terminal window, which is just the bash shell that we have, the command line into Linux. And what I can do, you might even see in there where I've loaded up the boot ROM. Oh, it's not the boot ROM, the boot image that we have for the SD card, the boot p2.bix. That's been renamed to a .bin. So that's a full version I can load in. Now, if you like, I can continue on with the more advanced features.
Something's occurring to me. It would be pretty neat, and I think we've talked about this on the forum, if you could make some little simple file system. It doesn't even need to have subdirectories, just, you know, a single directory that you could have a current, you know, rich state-of-the-art version of TAQOZ in. You can pull in, a user can pull in his library. Maybe he can have an auto exec kind of function to do that automatically on boot up. And then it would be like a really complete system that someone could learn in not much time and realize all kinds of things in. And just use that 8-pin chip that sits next to the P2. And that chip costs like, what is it, 50, is it $1.20 or something?
Yeah, that's right. About around $1 in quantities and so on. So that little USB chip that we have, that's on this board here. Well, you can't even see it, but it's only just a tiny little black thing next to the micro USB socket. And that's, you know, if I plug this in, I might just do that. I might just show you how I can talk to this particular board here.
And should we switch over to Ray to show us how this works with the ROM and then come back? Well,
yeah, no, that might be good, because I can adjust the font size in the meantime.
Okay.
Right, and while we're dwelling on the ROM, Ray can share his part. Thank you.
So Ray, I don't know if a lot of people understand this is truly built into the ROM.
Yes.
It's permanently there.
That's right. That's right. There's 4 parts to the ROM. One is Chip's booter that's there that will boot straight off, or it will take a serial command like the > space commands that you can go straight into TAQOZ, or you can go straight into the monitor ROM that's inbuilt. Or it can pass control to the SD boot code that's also in the ROM. So there's basically 4 sections of the ROM. Now, I was going to talk about the monitor section of the ROM. And so shall I go on to that now, do you think?
Yeah.
Okay.
And you could share a screen if you'd like. I've lost wherever your
yes.
video is because there's so many of us now.
Yep.
Yeah, sorry, I stopped my
That's
share.
all right.
Oh, there you go.
Okay. Now is my share up and
Yeah, now you
showing
got
the
it. Mm-hmm.
screen? Great.
A little more agreeable font size too.
Okay.
That's good.
In this section up near the top of the middle window, you can see where I'm moving the cursor, I hope.
Yep.
They're the supported commands that are in the debugger. So to get into the debug, I'll just flip over to a different screen, which is the Parallax serial terminal. So I'll just flip the Okay, so you can see there's a Parallax serial terminal on there. I'll just give a reset and a clear. Okay, so we've just rebooted our P2. Nothing's been run. The first thing I'll do is do greater than space and Control D. That dumps us straight into the monitor ROM. So you can see the monitor version 1.3, that's the ROM version. The asterisk is there waiting for a command. Now, the commands that we've got in there, you can put code into the RAM, into hub, cog, or LUT. You can dump out code from cog, LUT, or hub. So I'll do the list command in there now. So if we want to look at, let's say we want to look at 100 in cog, that's the data in cog at 100. If I want to look at 100 to 120 in cog, that's the data there. If I want to look at LUT, let's look at 300. I don't know whether there's anything in there. Yep, there's something in there, just rubbish. Again, 300 to 320 in LUT.
Ray, are those printouts little endian or big endian?
They're little endian. So, for instance, if I go 300 dash L,
oh, okay,
it reversed it.
gotcha.
So the L on the end of it says, I want it in longs. So I'll come back to the endian stuff in a minute. So if I want to look at LUT in hub, 1000, or again, 1000 to 1001, let's go, 1100. There we are in hub. Now, how do we look at below 400 in hub? Well, there's two tricks. When you're in the monitor, that doesn't matter because it can determine how many characters you type in. So if I type in 4 zeros, I will get hub. So it can determine that I've specified hub. When you're calling the monitor from your program, it doesn't know how many characters you typed in because it's just receiving a long. So the way I trick the code is that it needs an extra 1 in front of it. So 1 and 5 zeros will still get me hub 0. So that's the way you trick the monitor to dump out the lower section of hub, because otherwise it would conflict and it says, oh, well, what's the difference between 0 in cog versus 0 in hub? And that's how we get around it. So the next thing, we'll look at 0 in hub. and we'll list it in longs. Now, if we want to change 0 in hub, go 0 and we'll put a colon, and now I can start entering in some data. To see it's actually there, and you'll see I put it in the format little endian as I did it. Now, if I want to put it in big endian, and now I'll dump it out in big endian. I'm using a capital L, little l works, but it's easier for you to see. So you can see it put it in big endian format. So we can drive this with, in either format, depends on whether you put it in with a space between the bytes or no spaces. You'll note that the colon is the trigger for the monitor ROM to determine what it's got to do. And the one issue in there was I had intended to allow a space after the colon, but the code in ROM doesn't allow the space. So you must put the zeros and then the colon, or the number plus the colon. It's presuming hex. Now, what else have we got in there? Well, we can go straight to TAQOZ. If I press escape and enter, we're in TAQOZ. Unfortunately, I don't think we can come back to the monitor. Yep, Control D brought me back to the monitor. Okay, so we've been into TAQOZ. So let's go back into TAQOZ, escape and enter, and we'll do an LSI O, and we'll come back. Now, there's a few other functions in the monitor, and remember, we're actually running the code in the ROM that's been loaded into the top end of hub. So there's a couple of other functions we've got. I don't know what I've got on this card, but there's a run and a load function. So if I wanted to, and I won't do this, and I put in a file name 1, 2, 3, 4, 5, 6, 7, 8, and the extension without the full stop in the file name and extension, that would load that file into hub 0. Now, the exclamation mark says I didn't find that file, so it didn't do a thing. And I can do an R command for the same, which will actually load it and then execute it. So you can actually load a file off ROM straight out of the monitor. Now there's two other commands in ROM in the monitor that are intended for running with a user program. One is the go-to command. So you enter in the address you want to go to, followed by the G and carriage return, and it will go to that address. It actually does a call to that address, so it will retain on the stack its return address. So you can call a routine in hub, cog, lut, whatever, and return back to the monitor. There's also a Q command, which is quit the ROM and go back to the user program. So this whole monitor system can be called from your program. And not only do you have just the monitor to call, but you can actually call the routines within the monitor. So if I come back to, I'll change the sharing screen and I'll come back to my Visual Studio Code. Can you see the Visual Studio Code there?
Yep.
Okay. We'll just skip the little bit of setup. We'll just go to the routines. So these are the routines you can call from your program. You can call it from a PASM only program, but if you're running spin, because I use a fixed location in COG for the registers. There are 16 registers I use, and they're hard-coded in the ROM, of course. They're hard-coded to use 1E0 through to 1EF. And the spin interpreter uses those, so there's a conflict. I've got a soft-loaded version of the monitor that does all of these, shifts the code up into the ROM space and overwrites the ROM. And it can relocate these registers. Now you'll notice they all start with LMM. There's a bit of history with that. LMM stands for Large Memory Model, and that was developed by Bill Henning, where we could actually run code out of hub using a little 4-long interpreter sitting in COG. And so, and that ran at 1/32 the speed because it was 2 hub cycles before we could read the code, execute it, read the next long in. So this is a little bit of history, LMM, because when I wrote this code back in 2013, the FPGA we were using, hub exec wasn't even thought of at that point in time. So this code originated from there, so it never got changed. Now, if I go down to the commands or the routines, there's the serial init function that you can use. Now, this sets up your serial, and you have to define over here. You'll see in the right-hand side, you have to define X with the board, and LMM underline buffer address must be set to where you're going to put the data if you call the serial routine to read a character in. So that's a buffer that it requires, and that's where it sets it up. If you don't give it a buffer address, it will default to FC100, which actually overwrites the ROM. Actually, I think it might be FC000. Okay, so these are the routines you can call. Once you initialize it, you can transmit a character down here with hub TX. You can transmit a character with a carriage return at the end. Now, this little trick with this, you load the X register, LMM underline X, with the values that you want to transmit. Now, the very first byte in there, the lower byte, the lower 8 bits, if it's 0, it will output a zero as a character. So character hex 00. It will then shift that character to the right and see whether there's another character available to send. So you can actually send up to 4 characters in one long. But as soon as it detects that the remainder is all zeros, it terminates and comes back to your program. So we can transmit it. We can transmit it with the bytes reversed. That's what the REV is. We can transmit it as 8 hex bytes. We can transmit it as 8 hex bytes, but reversed. If we just use a straight hex, it expects to see a register called LMM underline F set to be a set of values. And if I just go back up here, you can see the hex routine. It wants it to be set to underline hex plus. If you want reverse, you put plus REV. If you want spaces between the hex output characters, you set space on. So there are a set of parameters you can actually overwrite to control the way it prints it. The string version is just a hub string terminated with a 0. So string version VER is the version number of this ID, so we'll actually see that it comes up with the message monitor, P2 monitor version 1.3. You can also output a string, and these two files here are the same. So if you put in your register LMM_P in COG with the address of a string in hub, and then call hub transmit string, it will actually output that string to your serial device. You've also got the lists, which are versions of dump. A2H is the common one. You want to give it 2 addresses, and it's in hex, and you call A2H. If you preset LMM_F to particular values, you can call hub list, and it will list out your memory as you've requested. So you can call within your program, you can call this listing, and it will dump out, as we've seen with both TAQOZ and with the monitor, you can dump out COG, hub, or LUT out onto your screen in 2 lines in your PASM code. So you don't have to worry about formatting, you don't have to worry about it converting to ASCII on the end. It does all of that for you, all within the ROM code. You can also call the monitor from your program. So if you call _hub monitor, it will immediately output the prompt, the asterisk character, and away you go. You're interactive in the hub, in the monitor, and once you've finished, you can return with a Q. So Q enter will return back to your user code. I think that's all I need to talk about in there.
Before we switch back over to Peter,
Yep.
Ray, maybe you can explain the difference between the monitor and what Chip's doing with Debugger, or Chip can.
Yeah, the debugger Chip is doing is completely different to this, where you're actually tracing your program as it executes. This doesn't trace your program as it executes. It gives you a set of serial functions like we used to have in half duplex serial. So it gives you a number of those plus the dump feature, which wasn't in full duplex serial. And that's really good when you want to see what's going on in memory. And you want to see what's happening. Whereas if you want to trace a program, Chip's debugger is going to be the be-all end-all.
And because this is built in for the noobs, that includes me and maybe a few others who are afraid to admit it, you could use this in conjunction with other tools.
Yes,
Then,
yes.
other languages, as you were explaining.
That's right.
That's quite unique. So it's like a real-time look into the state of things in the hardware.
Yeah. So here's a piece of code that is my Z80. So a number of you know that I'm writing a Z80 emulation for the P2. Heater wrote one for P1, and another guy, Jorgen, with the handle Pulmo. So here's where I'm actually displaying a set of registers. So I'm calling I'm just doing a carriage return. Then I'm loading up X with D equals. Now notice I've got D, and then the equal sign is shifted 8 bits. So this is, like I said, I can output up to 4 bytes in one command. So I've loaded D equals and transmit it. So it will actually send it to the serial port. The next thing, it will look up the address of disk drive. It will grab the value from the hard disk drive, put it in X. I'm saying I want a hex output, and I want it for a length of 2 characters. So I'll just get the lower byte, and it outputs the hex routine. So I'll call the hex routine. So this is physically calling the ROM monitor. I load X with space T equals and output it. So what this is actually doing, it's actually debugging the calls to the SD routines on disk. So it's actually loading up CPM. So this is the disk, track, and sector numbers that I'm debugging here, so that I can see what's happening. It outputs where it's going to put it in hub, which is a DMA address, and then I get more information. So this is just a whole series of calls, but I don't have to load up any other routines. They're all there for me. And I'll just go back up here one further. This is a different routine. And here's, I'm displaying a string. I'm displaying a whole pile of things with this call here. And then I call the monitor. This dumps me straight into the monitor. I can then look at memory, whatever I want to do, I can change it. And then just by hitting Q enter, I'll return to my program to the next instruction here. So this line here is exactly how I call the monitor.
And how about these example codes? Are these in the document that's on the first thread, or could we share them on that thread?
Yeah, they're all, I've actually got a whole pile of routines that I've posted up on there, exactly how to call the monitor and different examples of dumping pieces of code from memory. They're all up there. This specific one isn't. I could post that, that's not a problem. But there's lots of examples of using it. There's also the example up there in Spin, because as I said, you can't call the monitor from Spin. There's the alternative method of loading it soft. And there you can change where you want the 16 registers in COG that it requires.
Okay, so Peter's ready with the larger font size. Before we switch over, any quick questions for Ray?
I have. So Ray, it would be neat, and I think we've talked about this on the forum, if you had this thing ultimately available as an object that somebody could include and then call, then they could have a monitor program. Because
it is.
Okay, you've been working on that, right?
It's up on the forum.
Okay, okay, good. Because what's going to happen when I implement the debugger stuff, all that top ROM area or the top RAM area at FC000 and up is going to be repurposed for all the debug stuff because it's protectable, and that's where the ISR stuff loads from for the debug ISR. So,
yep.
So that
it's all up there, and it's soft loadable with two instructions.
Okay.
One is setting up. I have to go to it. One sets up the address in registers, and one sets up the address in hub. And so just two equates at the beginning, and they're objects.
Great, great.
Okay, Peter, ready?
Yes.
All
Thanks,
right.
Ray. Now, I've got it a bit larger now, so I'll just grab that screen there. Yes. And I'll share this one here. I'll bring it back up again. Where are we? Share. Everything's always easier when you have someone else do it. Okay. So we should
Much better.
That's a lot better. That's good. So what's happened now? I now have inserted the SD card. This has the full version of TAQOZ. It still doesn't have everything on it. I can load a lot more onto there. But what it does is have the kernel, as we do in ROM. It has the SD card and also a lot more to do with the SD card and FAT32, and then has an inline assembler that we can even write little code modules with interactively. And we see the listing for it straight away. Also has all the multimedia stuff with music and videos and graphics and so on. Yeah. Now, what I might do is just show you this. It's booted up off there now. I'll just do another boot again and just watch what comes up here. We just have a little startup text up here, which just tells us what the kernel is at the moment. It's chip kernel. Fair enough. I use a 4-letter code there. And these are the modules that are loaded. These are the basic ones I have at present. What we can see is we have VGA text, video player, wave audio, bitmap viewer, interactive. That's the whole interactive media module. And this is what you were referring to before, Ken, about being able to, that's a dictionary, and so I can forget all of that and remove it and put a new version in. Then I have the interactive assembler and everything to do with the extensions, the decompiler, and everything else. I can change the clock rate and so on. So at the moment, the clock rate is 200 megahertz. I'm just going to say, well, let's just do a quick little benchmark here. Then I'm going to change the clock frequency to, with a store sign, 300. Now, that's interpreted 300 not as 300 hertz, because that would be mighty slow, and I've run this at RC slow, and it is slow. But it's gone and said, okay, I'll scale that up to megahertz. And what do we have now? We have megahertz. A little bit faster, same clock cycles, but a bit faster again. Now, the difference is that we can just do this dynamically. I have VGA that's retimed itself. I have audio, anything else just retimes itself automatically when I change the clock rate. What we can't do, of course, is the COGS will have to do what they need to do if they're running a particular user program, if the clock rate changes. But that's only a problem if you're doing what I'm doing interactively. Now I'm going to just show you a few little features of this. I had all these IP cameras set up, and I found out I had a problem with IP upload bandwidth, so I had to cancel that. I can show you a VGA screen. So I might just switch the camera and see if I can show you the VGA screen I have here. Okay, now just check to see what I've got here. There we are. I'll just turn it around. Here we are. There's a VGA screen. All right, now I'll move that back a little bit so we can see it a bit better. And I have a scope there as well with waveforms and everything. But at the moment, the VGA screen is just VGA noise, uninitialized. You won't be able to see this, but you should be able to see this. If you can hear me talking, you should be able to see the VGA screen and the share screen too. So I'm going to say clear screen, which will just simply clear the screen. Easy enough. Now I'm going to change over my console to the VGA screen, so all output will be redirected to the screen. You might be able to see that there too. It's all redirected to the screen there. I'll change the actual, give it a blue. I don't know why monitors decided to do something of its own there, but I can do exactly the same on the VGA screen as I can on the serial terminal. Now, that's fair enough. I can also change the resolution if I come back here, clear the screen, change over to 360p, which is the 16:9 ratio, 360p. I should be able to hopefully come back here and then drop that down to 180p, clear the screen.
For anybody watching, you should be able to click on Peter's VGA and enlarge it.
Yeah, so yeah, I'm hoping that comes through from there, but you should be able to see you should be able to adjust your screen on Zoom screen, slider bar between the share screen and the actual camera view.
Double click on it.
Yeah, click on it and make one larger than the other. Just do that. So at the moment, all outputs on the VGA screen. I'll come back from there. This is just a quick, I'll do a directory of the SD card. Nah, it's probably a bit large for that one, so I'll change back to 360p, clear the screen, and do this again. All right, so we have a lot on there. What I'm going to do is tell it to hopefully do this correctly, view Tiger. There is Tiger, you can see that. So this is reading a bitmap file, palette and everything else. Do the same with Spider-Man here. In fact, you can see right down the bottom there, I happen to have text. What I'm going to do now is just change that and just make the last 4 lines a terminal that doesn't scroll anything else up. And then I'll view Spidey. There's my friend Spider-Man. And so that's how easy it is to get graphics up on there. We can draw graphics, we can draw boxes and lines and everything else. This is in between version. I'm going to redo the video player, so I won't demonstrate that today, and we won't have enough time anyway. But what I can do is simply do a few little things on here quickly. Here's a negative of that. That's nice and easy. I can vertically flip that. I should be able to vertically flip that. There it is, unflipped as well. And what I'll do is I'll come back to the main share screen now, because there's quite a few things that are on there and it'll just take too long to show you. So back to me. I'll just turn this around. Okay, hopefully we've got this around. Are we back?
Yep.
Yeah, I am. Okay, I can't see myself on here, that's all. That's the way it is. But so you can see me now, is that right?
Yep.
Yeah. Okay. All right. So back to the share screen over here. I mentioned before. I'm coming back to the console now. I'll do the same thing again. I can also play music. It's just all in there. So play. I've got popcorn. Oh, we know that one. What about tequila? We like tequila. All right. Does it play? No. Reason it doesn't play? Very good reason. I'll tell you why. It's playing for the P2D2. Tell it to play for the P2 eval. P2 eval. It understands that. Play tequila. Hopefully I have it set correctly. No, I don't. I'll just check this. Bring it back to that in just a moment.
Ken, is there a way in to get rid of the ribbon across the bottom of Zoom?
Did you touch it? Not that I'm aware of it.
Yeah.
No. Ray may know a way, or yeah, Ray Allen might. He has some tips, but not that I'm aware of.
Yeah. Yeah, I can't see what I can do about that right at the very moment, but I'll just try and scroll it up as soon as I do this. Make that a bit easier. So I should be able to do this again. Just make sure we're all mounted up properly. And play popcorn. Don't know what's going on at the moment. So
You were using pin 6 earlier, weren't you?
yeah, that's right. So I don't know what I'm doing at the moment. It's set up correctly. Although I might have a different card in here by the look of it. That's possible. I've been moving all these SD cards around. I don't know why that would be playing up at the moment though. But what I'll just do is just tell it to stop. I'll come back to that in just a moment. I'll think about that, and it's probably something simple. I might just show you a few little features that are built in. I mentioned the interactive assembler. Now, what's really good about it, if you look on the screen here, I tell it to turn on the listing because I'm going to do it interactively. We do up a new code word called multiply mul. What it's going to do is it's going to take two values off the stack, N1, N2, and return with the multiplication as N1 by N2, right? Okay, just like that. That's exactly what it's going to do. So to kick it off, I'll tell it to, now the stack is in assembler is referred to as top of stack A, little b, little c, little d. Normally I work with the top 4 items on the stack. So what I need to do is multiply 16 by 16 bit multiply from A to B. We want the result there. So A to B. I'm going to keep it simple at the moment. We can see the code for that. I'll just move up a little bit there. We can see the code for that one. I'll just put a little knock in there and go up. So we can see that we have the code assembled there for multiplying those two items. And that's all I'm going to do it with this one. I'm going to return. I'm not going to do anything extra. I'm just going to say N. How does it work? Well, the way it's going to work, it's going to take those two numbers, multiply them together, replace the bottom item with the product of that, and leave the top item. We'll see that at work. 1, 2, 3, 1000. Let's try it out. Mul. I should see the top item of the stack. Let's print out the stack. Here it is, the top item of the stack. Okay. No, I replaced the top item of the stack. That's fair enough. 1, 2, 3, 1000. And 1, 2, 3, the original item. So that's just a quick demonstration of how to use the interactive assembler. We can do far more complex symbols and branching, and it has a lot of, because TAQOZ is essentially a huge macro assembler, you create macros of how you might want to do things. So it doesn't require a separate macro part to it. Forth itself is the macro. So
Hey, Peter, how do you handle, I mean, you have all these names of mnemonics for the assembly language. Do you have to ensure there's no namespace conflict with everything else in the dictionary?
Yeah, that's a good question. Initially I did, and then I developed the vocabulary, which basically hides that away. So notice that I've just done words in there at the moment, which basically, if I wanted to find out the address with the TAQO, find the address of a code word in there, which was the multiply. Well, we'll use a different word in here. We'll use add. We'll see if we can find that. Comes back with a 0. It says it can't find it, yet that word is in the vocabulary. What happens when I type in code or I open up the assembler, start the assembler, it will then reveal those words so for the dictionary search, and we'll find those words and then hide them out of the way again. So we certainly wouldn't want to have them in the way, and that also puts them at the very start of the search as well. They're the ones that we want to find and work on.
Okay.
Yep. So
you
yes,
have some sense of scoping then.
Yeah. So there's well, we can. A lot of work is unfinished. We have a lot in there, and yet I still want to do a lot more to it. That's for sure. But having the assembler was, I just wanted to be able to do that, and it seems to have worked out quite nicely. And there's not much to it. The assembler itself is only a few kbytes of code. I mean, up here, I think I can even call that one up at the moment. I'll just look on the left here, just show you what the assembler looks like in forth code or TAQOZ code. Here we go. Look, some of these other commands in here, there's nothing in them. I'll just get rid of this. For instance, we're familiar with the drive low over there. Here it is. I created as a public definition. I've got this is actually a fourth word I've created, which says defer doing anything until the end of the line. But what it will do is we'll take this short value, which is the actual opcode, pass it through to a DCS destination, what have I got? Destination with a C and a Z, okay,
Right.
code, which is defined further back here, right back there. And that's defined very simply as another extra code that's built on top of this other one. Fourth is like that. We have layers, and we can just build on that. And so altogether, the first one only took up 4 bytes. This one takes up 4 bytes. If we look at that, we'll see that would only take up the 4 bytes in there. And so overall, the assembler takes up very little room. Even with TAQOZ, even though I expanded and put everything in it, all the code is still well within 64K. What I have done is move the dictionary elsewhere out of that 64K map, but the code can continue growing. So I think at the moment, it will report, if I just check usage, it tells me, yes, I have 40K of code in there, but that's a lot of code in here at the moment. As you can see, you play movies and everything else. And the actual dictionary, there's not quite 16K. That's not even reclaimed. I can reclaim private words. I use the spin pub and fry in a similar way. It creates a fourth word, just like any other colon fourth word. But the pry one says, look, if you want, when you do a reclaim, you can strip that header away and save that little bit of memory and also make it private. So we have those features in there. Now, any questions so far? Am I going too fast? Have I skipped over something, or probably have?
Peter, it's Johnny Mack in Hollywood. I have a couple of friends here in the industry that are quite interested in the Propeller now that I've told them that Forth is available for it, although it's obviously been around for a while. How would they go about developing a standalone app that just boots up and run? I do camera controls for a company in Spin. How would they do it in Forth? Okay.
It's all built in. So obviously I do apps all the time, products, and the thing, it's designed so that if I wanted to, for instance, play those notes, that's all I wanted to do, and show a graphic of Spider-Man or game. I just write the words, and once I'm done with it, as I might even just demonstrate right now. Before I had, I'll just find this particular one that I had before. I'll just show you very quickly. If I make this demo that I had before that played those notes, I'll put that in here, paste that in, demo, just double check that again. I did it. Very annoying, but that's in there. So let's make that, in fact, we're going to lock that in there, but I'm going to tell it to automatically start up. So the address of demo, the tick is like asking it to find the code address of demo. Let's even look at that code address, see what it looks like. There it is. That's where the code address is. And I can even see demo. I can look inside demo as well. Doesn't that look good? 9DC4. And
very cool.
there it is. Nice and easy. The 1C141, well, that's where the name is, and that can go and the code will still run. But over here, 6 pin, as you can see, 2 bytes, 2 bytes, 2 bytes. 3000 is actually encoded as 4 bytes because it's, but a lot of the smaller ones, 10-bit literals, will be encoded as 2 bytes. And the 100 is encoded as a special 16-bit word. And then you can see all the words in there. So we've done that. I can back up with a Control-B, back up to the card. It will stay there in between boots. But what I can also do now is say that I want to get the, I just want to make sure I haven't changed this, add that as an initialization in see, I've forgotten what I've got in here. So
Johnny Mac, this will become the tutorial to answer that question.
Yeah, that's right, exactly. So what I've done, I'll just fix this up here a little bit here at the moment. I think it's actually, it should be, no, it should have been plus in there. I'm trying to think what it was now. But it's definitely locked in there. And what happens is I have an auto start routine already, which goes through and does this. This is what you see when it starts up. That's already an auto start routine. But it will also go and check a whole bunch of initialization vectors and whatever order I put them in and go and execute them. So that's like your auto start. So when you turn it on, that's what it's doing. It's and you can still get into it, still develop with it, but it's doing the job that you want it to do. You log in remotely, it's doing the job you want it to do, and you can see what it's doing. You can even say, okay, what's the VGA? What's that set to? Oh, it's 640 by 480. Here it is. I can even reproduce whatever's on the VGA screen in text if I really want to, in one line. I showed Ray the other day. So it's sort of cool. Don't quite get 256 colors, but yeah, it's good. And so we can debug remotely with this. And of course, the command interpreter is already built in. It's just there. And of course, we can launch any of these apps in other cogs, which already happens now anyway. What I might just do is I might just find that particular word I just mentioned before. For some reason, I can't recall what I set it to. I haven't used it for a little while.
If you rebooted the P2 now, would that sound command run?
Well, it'll still be in there, but what I'll tell it to do, there's a lot of stuff I'm telling this to do, and at the moment, I'll just get rid of the terminal for a moment with Control-J. And I have very large fonts, so I can only read a few lines at a time, but that's okay. You can start to see what's in here. This is just part of the code that's in here at the moment. There's even parts in there that strip out headers and reclaim memory. Decompiler. Okay, and I'll just skip through that bit there, and I'll find out in here, in main over here, this is the main one that starts up on power up. So tell you what, I might even just make it nice and easy at the moment. I might change that and say start up on demo. So we'll start up on demo instead. So we'll do that. Now I'm still here. There we are. Auto on demo, please. Okay. Now back that up. I'm backing up to the MBR here, so I'm not quite sure where. Just make sure this is mounted up here at the moment. Yes, boot.bix. I might even just boot back up to boot.bix. So bix for short, and it will find the boot t2.bix file, back up to that. And it should actually execute the MBR one first. So I'm going to remove the power off this, which will be this lead here. Okay, no terminal, power's off, back in again. Hopefully it didn't do anything. Okay, but I've had trouble with this board here. It doesn't always reset properly for some reason. Hit the reset button.
All right.
So there we go. That was it. And we're in TAQO. So it's executed that. I'll do that again. I'll hit the reset button. Done. Easy. So it was very easy. Yeah, as you can see, no development tools other than a terminal and an editor. And if I'm out in the field and I have to make a little change, I can even do it off my phone over Bluetooth serial or USB serial from my phone. Make a little change, lock it in there. I can get out of there. That's a good thing.
Hey, Peter.
So, yes.
This fourth stuff is really neat, but you know, it's been around forever and a lot of people don't understand it. I think what they're not getting is this stack activity and then the naming, that really everything is a verb, but sometimes you don't use words that are verbs. So there's kind of this comprehension deficit out there. Is there any kind of like little thing that shows like some animation of here's when you do fourth stuff, you know, something that will visualize the stack, things going on to it, and then some word that's going to pop off a fixed amount and then do something with them so that people can start to see how this works?
Okay. You know, as you know, with Parallax and heavily into education, knowing something and teaching something is they're not necessarily the same thing. It's good if you can teach what you know, which also means being able to relate to your audience, who your students are, what their skill levels are. With fourth, I think the problem might be because they're familiar with other languages, and then they try to fit in.
Peter, can I stop you for a moment?
Yes.
There is that that book out, Learning Force. You gave me, I think you gave me a link on it. It's one of those very first Force books.
Yes.
With that little dinosaur, big pictures, and
yes.
Yeah, that is
the Leo Brody book, right?
That might be a nice introduction in the stack handling and all that stuff.
Well, yes, I think, yeah.
You should send Ken a link on that thingy.
Yes, I do have links in my Dropboxes. I should put it on my SourceForge page for starting forth, and also thinking
Who's
forth.
the author of that book?
Yep.
Leo Brody.
Leo Brody, exactly. Yeah, Leo Brody, and those books are really neat. I mean, they're neat. You know.
Yes, Peter, we need starting TAQOZ.
Okay, starting TAQOZ. Now, interesting thing is, you mentioned starting forth, and typically what people will do is get on a PC and do forth. It's no fun. You know, us guys, we like the silicon. You know, we'll go get the silicon and get motors hooked up and everything. And this is where the real fun begins with forth. Not on the PC. I never have any fun on the PC. I have the fun with micros. And
I got hooked up on the P1 because of MPark's Sphinx thing I could develop on the fucking P1. It was beautiful.
Yes.
I built it by myself, you know, on a breadboard and could work with it.
Yeah.
Heaven.
Well, you know, certainly if you use TAQOZ or TAQI on either Propeller products, you get things happening very quickly,
yes.
as we demonstrated with that demo, for instance. So yes, and it allows us to check out the hardware, because what I do with a new bit of a chip, a new bit of hardware, is I can try little one-liners, and yes, it does this, it doesn't do that. Here are the limits here, and I can actually be a bit smarter and cheat a little bit. And so
yeah,
I can make
I honestly would like if you could kind of compile some documentation for the ROM in inbuilt words.
Yes.
For you,
Yes.
they are pretty easy to understand because you wrote them. And
Yes.
yeah. Kind of write-only language, basically. You know?
Well, you know, like something like a starting fourth, but geared towards the propeller and geared towards robots and lights and blinking things and, you know, you name it.
Exactly.
That's what we
that
want.
would be great.
Yeah.
Yes.
But basically, what you can do with the ROM, because that is what exactly it is there forever, and you can do debugging, and you can figure out, and you can overwrite, and you can check out what happens running in a second COG and load some user program into Hub and check it out with TAQOZ and another COG. What the fuck is happening in the loop, or you know, that stuff. You know,
That's it.
So, Peter, maybe you can give us an idea too, like what are the limitations? Could you say run a couple steppers and take a serial input and make some sound? Or is that just not the intent and too much?
Well, of course, that is like I call that very simple, you know, like serial and everything. If I had all the setup here, I'd be able to show you right now how I could do it with one lines, right? And, you know, like if, for instance, up on here, if I was making pin 54 on the oscilloscope here, an output, I'd say 54 pin, as we have the syntax before, select a pin. I want to make it 2 mega board transmitter. That's it. Yes. I want to print hello world to that. Here's a string, hello world. Hello world is a string here on the stack. And I'm going to tell it just to transmit that data to the scope. I'm going to check my scope now. Believe me, it came up on the scope. I might even show you that one. It came up. It just, that was how, now did that switch around? Can you see that?
Yep.
Yeah. So you can see that decoded in there perhaps. Maybe, I don't know. That mightn't be set to 2 meg, I'm not sure. But if I have it set correctly, then hopefully we should be able to make out what it is. But it definitely came up on the scope, and I don't know if I've triggered it right, but I'll switch back now. This is one of the things I had set up really nicely, the scope and everything, but not at the moment. Next time I can show you a lot better. Certainly, we really want the P2 to be the test instrument. So if I can have the P2 displaying that, that would be really good. Now, that's all it took to transmit it, hello world at 2 megabaud on pin 54. And of course, as we know, we can have, a chip has put that range in there, so we could actually have 32 pins. I could say, okay, 0, 32 pins, 0 space 32 space pins, hello world, transmit 2 megabaud out all 32 pins. That's an amazing thing about the P2, absolutely amazing. But we can do it all in one line with TAQOZ. Yes, we can do it with an IDE, we can do it with conventional languages, and you know, people are going to do that because they're going to work in groups, they're going to use code from here and there. But if you're an engineer, I'm primarily hardware guy. I can get into the hardware. I love it. You know, whatever's on here, whatever's on that board, I can get into it. I've debugged and reverse engineered so many different bits of hardware simply just by writing a little forth, running it on there, and I'm doing things with it that the manufacturer never intended. So this is a P2. We can do a lot more with that. Yeah.
So this is really excellent, but Forth needs to bust out of obscurity because kids could program in Forth, but I don't think there's any kind of like on-ramp. You almost need, or let's say it is needed. You know, when you get a smartphone, there's no manual with it, right? But it can do untold things. So it's all kind of intuitive. You know, and when you play a video game, like these modern video games that take 30 hours to play through, as you start to play the game, they teach you the moves on the controller and you incrementally build up. So what if there is some way to make a Forth intro thing that taught Forth in the course of posing programming challenges and then showed what was actually happening with the stack so that people could familiarize themselves with these concepts and draw good inferences that they could then use to like really juice the learning.
Yeah, that is a project in itself, you know, a real project for
it's a lifetime.
Yeah, And I would know like that, okay, I've seen people who have been teachers or been in that industry where they're teaching, and they will develop some material for that. And you have to know what your target audience is. What level are they at? What do we need to, you know, like I skip over basics all the time. And so what I need to be able to do is work out, okay, I need to go through basics, don't spend too long, it gets boring. Let's do some fun stuff. You're playing the piano, you want to play a song. And so I want to be able to show them how to play a song. Then we'll come back to you know, what's important about that song and the notes and everything else. So what I think you can find on here too is that I was going to show you something else. I'm just trying to think what that was now, but oh yes, debugging, because we're talking about learning. Well, you were talking about the stack before, and I said, look, okay, 1, 2, 3, 4. Here's the stack, and there they are on the stack. There's 3, 4 on the top. We add those together. What do we get? We get the result. All right. So that part's in there. That's easy enough. What happens now if we want to trace that through? I'm going to trace 1, 2, 3, 4, add them together. Oops, I don't know. Oh, that's okay. That's only a comment now. That's nothing. So there's a plus and an untrace. Untrace. This is what happens. We have a real-time instruction tracer in here. It's just listed what it did, where it went to, and the contents of the stack. So as you can see, the 1, 2 went onto this. I already had a 2E on the stack from previously. Then I added the 0C or the 12 and the 34. They're added together, and the result happens to be 46. What about if I do something more complex like demo? I trace a demo program through. Let's see what happens. Wonder how this works. That's it. So we can even see everything it did right up to the very last before it went and told the pin to turn off the smart pin features with a mute control. That's in there. So
that's really useful, but it's too bad there can't be some kind of real-time, always running thing that is just sort of there in the background if you want to look at it, to always correlate, you know, what's going on with visual stuff.
Yeah.
So that people can then really get a feel, because this is still a little abstract.
Yeah, sure. I'm familiar with all the ICE tools and, you know, all the tools that you need, JTAG tools to get in there. But remember that when you're dealing with fourth, you have this dictionary of words. There's a dictionary of words that are in there. I'll just put a short list. We can get into each one, exercise each one. You know, you're not exercising the whole program. You can come in. I'm just going to check out demo or hertz or whatever it is. I can test it out and say, yes, that works. That's fine. There's no problem with that. And so it's a different way of dealing. It becomes its own debugger in a way.
Oh yeah. This should I don't really know much about Python, but I mean, this is so simplistic and so I mean, if you understand the concepts, it's very usable and you can build on it. It's very minimal, so there's not a whole lot to get lost in. So this is like a significant thing, but it's fourth is like ever obscure in the world, but it shouldn't be that way.
Yep. You know, I understand, and I don't understand. I understand and I don't understand why that is so, because it's a tool. To me, it's for hardware, it's the best tool ever for debugging, testing, reverse engineering, making things happen. And I like to make things happen. And that's why I use Forth. I like to interact with it. I want to see that working. What happens now? And so that even the SD card, same thing, right down to the very lowest level, I might even issue the command just to initialize it. There we are. Gets a 1 back. Yeah, this is really great. But what about the 8 command? What do I pass to that? What do I get back? Okay, and what do I read back from that? And I'll read back the results and so on. So even that, what am I doing with command? What's that doing? I'll decompile that, okay? Or decompile it this way, command. So all the tools are there. I remember some of my early projects and I'd have the logic analyzer and the oscilloscopes and storage stuff, everything hooked up. You spend so much time setting them up and then miss the event altogether. But here, I just make the event happen and capture it as I need to. With a P2, as you know, we can just capture events so nicely. It's beautiful. And we have the memory for it too. So,
Peter.
Yes.
So I noticed that you use some commands that are obviously coming in from your newer version of TAQOZ, because I don't have C or decomp or any of those. So I guess I've got to download that and overrun the ROM to get those commands.
Yeah. Yes, exactly. That's why I'm just showing the more advanced features in here. If you can put that onto an SD card and load it in via that, or you can also do this little trick. I might just show you. I'll pull the card out. Pull the card out of the P2 board. So it's going to be totally blank. It's going to be, yep, nothing. I can talk to TAQOZ in ROM, but nothing else. Over here, I'm just going to load in with the Python loader that we have. So I think that was Python 3, oops, wrong one here, over here, Python 3. Just to make sure I had the right version there. And what was the name of it again? I can't remember the name of it here now. It's OzPropDev's loader. So I use that particular one. I might even have called it load P2. Okay, as well. There is load P2.py. So so Python 3, load P2.python, and then the name of the file that I want, which is going to be boot P2, and it'll just fill in the rest. Here we go. Scanning ports. Try that one again. I don't know what. Oh, I've got to disable my terminal there. Do that again. Here we go. Loading in. Loading complete. Whoa! Up comes the VGA, and look, everything else is there. So we have the complete boot. TAQOZ reloaded, loaded in serially. If you can't get onto a card yet, put a card in. Once you do put a card in, then you can format the card. Even if it's a 64 gig card or anything, you can format that to whatever you want. For instance, I'll mount the card now. Maybe, yes, there it goes. Didn't like that. Let's do that again. Just put that back in. And it's all in there. It knows where it is. I'll get rid of this screen over here. I'll shrink that one down. You can see that's happening there. So we have all the tools in here. What do I have to do over here? Never click the right one here, do I? Okay, so back over here again, and so there we are. We can talk to the SD card and do whatever we need to do now. So yeah, load it serially. That I left the command there up on the forum, but if you have Python, just load up OzPropDev's Python loader, and the code's there, and load up the boot P2 file. Easy as that. Now, is there anything anybody would like to see? Because we've been on for a while now, I think. I've been losing track of the time here.
Yeah,
so
we're an hour 40 into it, so we could take any final questions.
Yeah.
There are a couple coming in. I was just curious, when you were showing all the VGA work, were you running TAQOZ and using that as your terminal?
Yes, I was using the serial terminal's keyboard, but I was diverting all output from TAQOZ to the VGA screen. So, and of course the VGA screen, the routines there were, because I can make, in TAQOZ, I can create input and output devices. I can say, this keypad, this little keypad I come up with here, or touchpad, this is the input and this is the output.
Okay, that makes it more interesting for education for sure. Well, I have to say, I mean, the first time I got a P2, the Rev A, and I called up Chip, I said, Chip, how do I program it? What do I do? I hooked it up to terminal, and then I accessed TAQOZ, and I didn't know what it was until I read on the forums. And then at that point, like John said, I wanted some examples.
Yeah. So perhaps, you know, like just understanding at what level we have to come in with examples. You know, when I first got into the P1, you had this tutorial in your manual, and for spin, And I got the demo board and I plugged it in and I just went through that. I tried that and a bit of code out. It works. Then I tried modifying the code till it broke and it changed,
Yeah.
and I could understand it. That's what I loved about it. It was almost interactive in that I could just hit the F11, load it on the board, and it was working straight away. So doing it like
You know,
that.
in our educational classes, we have teachers who've never put anything electronic together and are just wiring a resistor and LED for the first time. And then side by side might be a university prof who wants this kind of look and will blink the same LEDs for a whole semester and understand the hardware and wants the abstraction removed. So there's an audience for this with them, for sure.
Yeah, Jonathan Titus left a little chat thing here. He said, these days people, kids in particular, do not read. They need graphics that show how things work. To me, that would be the way to teach fourth, not by showing a monitor and how numbers go on a stack. It won't grab kids' imaginations. Make it a game. If you could make a game to teach fourth, it would absolutely go over. But it would require some kind of animations to help them understand what it's doing.
Well, I think it's really an accessory tool for people's product development.
That is a practical use, but it could be the language that kids learn, you know, because it's very straightforward. Well, if you can understand what the process is, it's very simple, but it's not, looking at fourth doesn't, it looks completely meaningless unless you're tuned into the idea that things are going on a stack and words are popping things off of stacks. And some words are putting things onto stacks. If you understand that business, it could make sense. But like the first time I looked at hardware description language, like Verilog, I just couldn't figure it out because my mind is fixed on proceduralism. And that's not what goes on in a hardware description language. It's just a bunch of like concurrent declarations, logic equations. And once you get your head around that, it's easy to understand, but this is what fourth suffers from, this kind of a conceptual problem.
Yeah, so I think, you know, we talk about perceptions, but this is true of anything that's different. We're learning a new spoken language, we're learning new computer language, we're learning new chip, P2, and all the, we're still learning about that, by the way. But the thing is that, yes, it requires effort. We're talking about the kids today. If you make it, we're making it very easy for them, but once again, they're abstracted from it. I remember back in school, if kids really wanted to find out about things, they put the effort in. So yes, I don't know. Well, you know, of course, we can wrap fourth up and put code blocks and everything else and so on around that, but they won't really learn the language at all. They won't ever really understand. Yeah.
One of the, if I may, one of the things that I find really useful, and I'm not a new learner nor a young guy, but one of the things I like whenever I'm going into new environments, be it VHDL, be it any kind of programming language, is I'll look for something called a cookbook. And that is basically little snippets of things that people routinely do and show me how to do it in language. Seems to me that when you've got a fixed set of hardware attachments that you have for the Propeller and little example things that you do in class, that having a cookbook recipe-like thing for how to do this in the fourth, how to do this in the spin, how to do this in PASM, and have a nice index list, that would move us a nice step forward to being able to see it in all three languages. Chip, it really doesn't address your, how do we introduce RPN? Because that's a mindset change. It's kind of like object orientation, or your asynchronous VHDL stuff. But the net result is there's teaching RPN and getting people to think about that is a different problem than teaching how to work with how to light an LED, how to drive your VGA, and when you've got these words here, example use of the words seems to make sense to me, that if I could just take a topic, search for it, and you show me 3 different variations of the thing when I search for it, I'll be able to get there very quickly on building small designs.
Yeah. If you have any knowledge in one of those bases, it'll you'll make good inferences in the others.
Exactly.
You know, what Titus was saying, think of this. If you had to teach a language using a game format, would fourth not be hands down the simplest to approach that way?
There is
Because
something on that, yes. Yeah.
if you had some graphical helper,
think about that Minecraft game where they build computers with kind of blocks and water flowing to simulate whatever CPU. If you could visualize the force stack kind of in 1/3 of the screen. I mean, I'm thinking right now about that program which we had New Zealand, the guy out of New
Oh
Zealand.
no, 12 blocks.
Not 12 blocks, the debugger thing he had, where you could watch same guy.
Yeah. We forget the name of the tool, but we know what you're talking about.
Yeah, and there you could basically even watch the pins while accessing your, I loved it for the first half year, and then I never used it again because I didn't need it anymore. But something like that to grow the RPM notation, I still can't handle force. I would love to. I would love to, honestly. But, it's fighting with me. It's one. I mean, I'm multi-language. I'm programming since, I don't know, 30 years minimum, maybe more. Tons of languages, but force still fights with me.
Well, just mentioning just on learning a language, we're mentioning about examples and code snippets. When I look at, we got stuff on Wikipedia or wherever it is, well, one of those ones that, how do you do this in different languages? Yeah. Most of the work that you're doing and trying to learn is how the compiler works, how the syntax and why you should do this and how you declare this. In fourth, I have got nothing to show you. I just say print hello world. That's it. That's all I do. If you want to know how to turn an LED on,
the basic interactive thing. I mean, that is what I started with early on, with some basic computer thingy, and you type in and it works. I mean that. Hello world, go to 10. I mean, and you type it in and it works immediately. I mean, that's it's the optimum thing.
Yes.
And that is why I'm so attracted to force, even if I can't handle any of that.
Well, one fit that I see is
Australian reverse.
Peter, we have some educational customers in university who just give a couple of resistors, LEDs, a speaker, and one sensor and spend the whole semester in engineering classes understanding architecture and programming in different languages around a small pile of parts.
Yeah, and TAQOZ, you just have to say 56 blink.
Yeah, TAQOZ might be another tool they would use.
Yeah, exactly, because it's just like I said with that tone before. It's just we come back into it and 6 pin 1 kilohertz. It's like, okay, what happened there? No idea. I think I've got the speakers hooked up there. What has happened to it? But anyway, come back to that later. You know what? The speakers are probably playing up. That's why I can't play any music. But yes, so certainly being able to turn LEDs on and off, making a pin low or pin high, very easy. You just say, this is what I want high, this is what I want low, reading a pin, loops. But the interaction, this is what it comes back down to, being able to split everything up, or break everything up into small chunks, testable chunks. Yes, this does what I want it to do. This steps through to the next step of the stepper motor. And it goes through all steps and repeats the sequence. Good. Now I can move on to the next bit. So creating, writing programs is more about creating those snippets. And then they are very small snippets.
I think this has a lot of similarities to what I've seen with the MicroPython efforts.
Yeah.
So it'll be fun to compare this to that and see where all these tools work well as we go on with this. And I think we should come back with another presentation here that's like even a getting started, because it's understood that in the beginning, all the experts, you guys understand everything, and others need to learn about it. So it'll get easier in time for those who actually want to hook up TAQOZ. So we should come back and do a very first LED sound, get the tool, install it kind of thing later.
Hey, can I say something extra?
Chip.
About using an animation to demonstrate what Forth is doing. It is so simplistic that of course you could just show values going onto a stack, but that doesn't really, that may not grip a kid's mind, but what if you could show like a little man picking up something and then putting it on the stack, right? And then again, putting something else on the stack. And then he goes to some other guy who then takes two things off the stack, does something with them, and then puts one thing back on the stack.
Yeah, that is exactly what this book does from
Exactly.
Rodrick,
Yep.
because they have animation on every side with, I think, dinosaurs or whatever stacking stuff. It's wonderful.
Yeah, they're simple little line drawings, but they are quite effective.
Yep. And that one could easily do into a slideshow with Raymond's slideshow from SD thing.
Well, it needs to be like an
binary
animation.
and run the slideshow.
So yes, we could use a PT to animate it on the VGA HDMI screen very easy with the memory it has now. We've got no problems doing that too. So we can. You know, we just have the higher level of abstraction there, and it can go through, and just like the trace feature was going through, grabbing each instruction. Well, the high level animation can go through and show that as well. So it's quite possible.
Yeah, but the main thing I would like you to do is to give some beginner-friendly documentation what them words do in the ROM version of TAQOZ.
Well,
which is kind of a reduced set of what we have, because you are happily changing it every week. But the ROM version is stable, and if we would have some more detailed explanation, that would really help. Because for you it's easy to understand what the words do, but for me, I'm sitting there and thinking, oh yeah, I have a list of words, but what exactly do them? How to use them?
To break this down with an animation tool, you'd actually have to overcomplicate it, because what's going on is so simple, it's almost, you miss it. So you have to over animate and show someone like picking something up, putting it down. Another guy shows up with another name from the dictionary. He looks different. He does his thing. And just, if you could show it like that, it would get the idea across.
Yeah.
Well, I wonder if we can use the cartoons, the graphics that they have in the starting Forth book, for instance. I'm not quite sure about that. We'll have to look into that, but they're very good. You know, I loved that book when I first got it, and I learned Forth with that starting Forth book. And you got it straight away. You could try it out. You go, yeah, it does that. So it's good.
Yeah, if you could kind of find out if you are allowed to. I mean, it's online, you know, so maybe with links on the, I don't know, but I found it very good also. Even if I still don't hear, but that's that reverse. It's a write-only language, you know. I'm a COBOL programmer, which is exactly the opposite. I mean, it's the most wordy language existing. But you can read code written by other guys 60 years ago and understand it, because it is as wordy as it is, and Forth isn't.
There's that's a discussion. I think Forth is a discussion in itself, and how you can teach it as well as another discussion. But you know, as I showed right from the beginning there, TAQOZ and ROM, this is it. Yes, it's limited, but it's not. You can actually develop everything if you really wanted to. And the thing is that you can start testing it. Look, the chip is pretty good. Once you got the power on it, and you've got a serial terminal hooked up, if that works, then you can test out the chip, test out the hardware, do everything that you need to do to really debug it. On my P2D2, just mentioning briefly, like for instance, even though I have the SD in there and everything else, if I hold down the reset button for a second, it will actually force it into serial load mode, which is also same as going into, you know, auto boarding into the TAQOZ monitor. So you can just go straight into that as well. Which, by the way, too, just mentioning that, when I do a serial load, I don't have to pull out the card or do anything. It just automatically says, yeah, look, serial boot only. Ignore the flash and ignore the SD card. And that's the beauty about that $1 chip. I can do so much with it. It's fantastic. Yeah.
Well, Peter and Ray, I want to thank you guys for all this work you've done in sharing it. It's amazing the traction of the forum thread as I was looking at it.
Well, this has been really good too, Chip. You know, just being able to, you know, like I don't really want to talk about it. I'd rather just do it. And I had so many hassles with setting it all up, but it's okay because, you know, when we have a challenge, we have to have goals, and the first part of goal is go. You know, just go for it. Just do it.
And well done, well done. I also have to say well done to Cluzo, and I hope he comes out with that Z80 and CPM.
It's booting.
It's itching in my fingers because my Microsoft Z80 COBOL compiler does not run under the P1 version. It runs into some error I can't really understand. So I hope that your version based on Pulmols little bit, maybe it does that opcode which is missing for Microsoft COBOL. My dream is really to run COBOL on a P2. I mean, that would be gorgeous.
Well, you know, it's probably got the, you know, how much power did the mainframes have back in the 60s? You know, how much memory? Yes, I think yes. You know,
less than my phone.
If we get CPM running, or I mean, I'm hoping for MPM because we have the memory for bank switching. If you could get MPM running, it would be, wouldn't it? I mean,
Okay, any final closing up comments here? We're coming up on 2 hours.
Yeah, all right. The last comment would be that we have to find Heater and explain to him that he has to do an IBM 390 emulator for the P2. Then we can run ZOS.
Well, you know, just write all those in COBOL compiler in Forth itself. No problem. Okay, no problem. And I'll only take up 20K. Okay.
Oh, I just get to play with.
Do you want to see 30 seconds of the Z80 running?
Yes.
Sure, that's a good way to wrap it up.
Okay, where's my screen?
I'll get that off.
Okay, find screen share. Okay, I think you've got it up on screen. Do you see the first line that's got P2 Propeller 2 latest?
Not
Got a 1 in the
here.
corner for some reason. Hang on. Okay, is that better? Yep.
Yes.
It needs to be on the right screen. This is running the Z80 emulation, so compiling it straight out with fast spin. So that's a bit there. That's the program size. We come here and it's starting the terminal mode. It detects P2 eval board. That's my experimental version. It's loaded the SD driver into COG1, initializes it, finds the directory, and it finds all these files. These are all CPM disk files. So on the SD card, I've got an 8 megabyte disk file for drive A, another one for B, etc. And then it starts the code. So the code at first jumps to 0 on the Z80, and this is what's in my registers. What's in the ALU, what's in the effective address register. The opcode it's going to pull out of memory. So I display the first 4 opcodes, first 4 bytes. The way the Z80 runs in my emulation, I have 3 vectors. A 12-bit vector called vector 1, which is an address that'll execute a certain set of program instructions. So Z80 is broken down into basically can do 3 different sections. So it will do the first bit, that's the second, that's the third, and that's what the PC counter will be after it increments. So the first thing it does is it gets an execute of a jump instruction to FF00. That's what it does. FF0 does this, and that just comes straight down. Now, when it does a read or a write out to an IO port, I have an extra bit of debug information. It's just writing out to that register, which is a 0E. It's a reset command, and it does a whole pile of those. And we'll go down here, and then it starts writing to the port, the SDIO. And I'll just zip right down here, and it's going to get to a read instruction. And it's waiting for a read. So if I just hit enter to read, it'll go on, and now it'll go. And what it'll actually do, I won't waste your time watching it. It'll run for about 2 minutes. It'll actually load the first 10K off the SD card from that drive A into memory, and it starts executing it. And it comes up, it does the first set of prompts, tells you that it's running 64K of CPM code. But unfortunately, something in there is not quite right, and it ends up going back and doing a whole reboot and follows that again. So that's where I'm up to.
Okay, cool. Go.
Oh, Ray, can I have a Timex Sinclair 1000 on my desk with all this? That's how I learned BASIC.
Yeah, isn't it? I had a TRS-80.
I don't have any 8-inch disk drives, floppy disk drives at all. Do I need that?
I have an 8-inch floppy disk. Is that any help?
Good luck.
Oh, I cut my teeth on a mini computer, and we had disks the size of washing machines. A 10 megabyte disk drive was worth 16 grand.
That's it. Yeah.
Yeah.
That's great. And by the way, you mentioned it at the start. You mentioned the ones who originally did this on the P1. You mentioned my name, but I think you meant Heater. Wasn't it Heater that did
Heater, yeah. Yeah, Heater did ZyCog.
Heater did one emulation, and Pulmol did another one. And
yes.
They were kind of completely.
Yeah, Pulmol's with a better implementation of the Z80 extra instructions.
Yeah, he went deeper in it.
Yeah, and I've used that as a basis of writing this.
Cool.
So at the moment, none of it's using all the special features of the P2. So it doesn't use the skip instructions and the execf and all of that. But it takes.
Get it running. Just get it running.
Now,
yeah.
I'm just seeing from a few of the messages. I haven't been able to read them properly at the moment, but I think everyone's excited enough to start playing, start doing things. And, that's what it's about, isn't it? If we're excited about it, it's like, what do we say? No effort, no joy, but playing, there's no effort involved in it if you play. And if you play and you have a lot of fun, you have a lot of joy out of that, and you're very productive. And that's what we can do with P2. The whole P2 itself, I love it. Hardware-wise, I can plonk it down on a board, any pin, whatever I want it to be. That's the pin I want. I can, and the ARM chips and the headache.
Yeah, and the fact that this is built into ROM, we're still selling basic stamp 1s at Parallax from almost 30 years ago. So I can tell you in 2050, there will be people playing with TAQOZ.
Exactly. Yeah, exactly.
And they'll say
That's
over
the
100 years ago,
reason-
this language was invented.
That's the reason we need some serious parallax documentation. And
Right.
Peter has to start it, and then parallax has to do something like what's a microcontroller with
forth.
Yes.
That's
It
a,
is
that's
very
a lot of work.
important.
You
It's
realize,
important.
yeah, you realize that if I do this, it's like it's reverse Polish notation. I'm down under, and it's a propeller. It's totally different. So you know, where do I start? It'll be fun.
Difficult. Yeah, it's difficult. But I think, gosh, I wish I would understand that language. Then I could kind of really. I mean, it's itching in my fingers, but I can't get over that anti-COBOL reverse
Daddy.
Australian stack notation thing.
Okay,
But we'll all
so
have fun.
let's wrap it up. Peter and Ray, thanks again. Thanks for everybody joining. We had 80 people register for this tonight,
Yeah.
so it was a really good start.
That's really good start, yeah. And it was a really nice presentation. Somebody has to say it.
Yeah, excellent.
From both of you. I thank you very much.
Yeah.
You have put a lifetime of work into this already.
Yeah.
And,
Yeah,
you know,
thanks, guys.
He's Chip here. You know, he's just listening in most of the time, and he's just been hunched over that grinder the whole time, coming out with the P1 and the P2, and we're all just having so much fun with it. You know, if I didn't have the P2, I wouldn't have much fun with micros. Not like I do now. Thank you, Chip. Thank you, Ken. Thank you, Parallax.
It's great to hear. Yeah. Well, I
You
think
guys all
there's enough
contributed
to
to
work
the whole
with here.
thing.
Yeah, we have 20 years of fun ahead of us now.
Yeah,
learned so much along the way from Chip with all the different FPGA versions and how it all works and hangs together. Really, really good info.
That was a very nice ride for the last 10 years. Yes. I mean.
He has persistence I'll never understand.
Yeah. I mean, the horrible thing is that when everything is solved, you go to the Parallax forum and nothing happens. You are lonely. And
Well, you guys can regroup in a little over a week.
I mean, honestly, I'm addicted to that. Every day I have at least to read the news post, and something could happen. Gosh, guys, I love you all.
Michael, you should get a webcam, Michael Summer.
Yeah, I'm actually not really. It depends on the moon phase, you know. Sometimes I'm not visible, hanging from my rafters, you know.
And one last thing here, Jeff put out Alpha 3 of the Propeller tool today.
Oh,
and
cool.
Yeah, some of the download issues with P2 that looked like an error, but were really not errors. So yeah, here's a GitHub link.
By now I already like the new Propeller tool. It's pretty nice integrated, kind of. Go for it. I mean, it would be nice. It would be nice to have the possibility to also select Flex, Eric's compiler and or OpenSpin, because I mean both of them are there. If we could kind of get some buttons for them.
Yeah, well, actually, that's the subject of a presentation in a week or two.
Okay.
That will be lively as well.
Okay.
Okay, so
having that integrated in the prop tool, it would be dreams.
Oh, I can imagine the discussion that's coming.
Okay.
I just can't imagine that topic's going to come up.
Okay. So we are on the same level, I see. Okay. Right.
All right, everybody. Thanks so
Okay,
much. Have a
okay,
good
guys,
morning.
I'm
Good afternoon.
getting out of here. I find out how.
When I hit the end button, we all say goodbye. So see you
Okay.
next week. Thanks.
Thanks,
Thank
Ken.
you all very
Thanks,
much.
Bye.
Chip. Thanks, Peter.
Goodbye, and
Thank you, Rod.
have a
Thank you.
wonderful
Thank
evening,
you.
guys.
Good day.